Hello and welcome. In this video, we are going to look at how to solve exponential equations. Exponential equations are equations where we have exponents or indices, so say 3 to the power of x, and we want to solve these for x. These equations may seem tricky at first because of the exponents, but by the end of this video, hopefully you'll be able to do a problem like this and much harder ones very easily. So let's start with this problem though. So we have 3 to the power of x is equal to 9 to the power of 3. To solve this, the first thing you always want to do is to get your two bases the same. So we want our bases, so our bases are 3 and 9 here. We want them to be the same number. We can see that we can do this by making them both 3. So we can have 3 to the power of x, and to make 9 into a 3 for the base, we can do 3 to the power of 2, because 3 to the power of 2 is the same as 3 times 3, which is 9. And now both of the bases are the same, and we haven't changed anything other than rewriting 9 as 3 to the power of 2, and then we have our 3 that's still on the end. And if we simplify this a little, this is the same as 3 to the power of 2 times 3, which is 6. And the very last step is, once you have the same base, you can drop the bases and just have the exponents. So if we do that, we're left with x is equal to 6. And that's our answer. Now let's look at a bit of a harder example. 1 over 27 is equal to 9 to the power of 5x minus 7. And we want to find x. So to do this, we follow the same steps, only this time it's a bit harder. So we want to get our bases to be the same. And by looking at this, you should be able to see that one good option for a base is 3. Because we can easily turn 27 into 3 as well as 9 into 3. And it doesn't matter that 27 is on the bottom of this fraction, as we can move it to the top using a negative exponent, as you will see in just 1 second. So to do this, we get 1 over, and we want 3 as our base. So 3 to the power of what is 27? 3 to the power of 3. And that is equal to 3 to the power of 2 to give us 9. And on the outside we have our 5x minus 7. And if we do some simplifying, remember we want 3 as the base, not 1 over 3. So as I mentioned earlier, we can just go 3 to the power of minus 3, because 3 to the power of minus 3 is the same as 1 over 3 to the power of 3. That's one important thing you should learn with negative indices. And that is equal to, if we expand this out, 3 to the power of 10x minus 14. And now that we have our bases the same, as they're both 3, we can drop those bases and just solve this. So we are left with minus 3 is equal to 10x minus 14. And now let's get rid of this negative 14 by adding 14 to both sides, giving us 11 is equal to 10x. And if we divide x by 10, we are left with x is equal to 11 over 10. Now, for this final example, this one is the most tricky. It doesn't look tricky, it doesn't have many numbers, it's just 3 to the power of x is equal to 8, and we just want to find out what x is. But the reason this one is so tricky is because we cannot easily get a base that is the same. So we have 3 here, we can't easily make 8 into base 3 as 3 to the power of 2, or we can't do 3 to the power of anything to give us 8. So we're going to have to do something different to solve this one. When you run into problems like this, what you're going to want to do is take the logarithm of both sides. So if we do that, we get log 3 to the power of x is equal to log 8. And this works because we are not breaking any rules, as what we have done to one side, we have also done to the other. And next, using our log rules, we can see that our x up the top can come out the front. So we can do x, bring it out the front, to get x times log of 3 is equal to log of 8. And finally, to get x all by itself, we have x times log of 3. So we can divide both sides by log of 3 to get x by itself is equal to log of 8 over log of 3. And that's our answer. And if you have a calculator with you, you can type log of 8 over log of 3 into it to get a decimal version of x, giving you x is approximately equal to 1.89 to 2 decimal places. I hope you found this video helpful, and if you did, please consider liking and subscribing. See you next time.